In this unit, you will learn about density, specific gravity, pressure, ways of measuring pressure, and Pascal's principle. In the picture, a person is having an easy time lifting one box and having trouble lifting a second box of the same size. We all learned about differences in weight early in our lives. Let's go one step beyond recognizing weight differences by considering density. Density is mass divided by volume. If both of the boxes shown have the same volume, which box has the greater density?
Correct.
What is the density of a box that is 1.2 meters by 2.5 meters by 3.0 meters and weighs 50 newtons?
Correct.
The symbol for density is usually rho. Using this symbol, the formula can be written as rho equals mass divided by volume, where mass is designated by m and volume by v. The SI units for density are kilograms per meter cubed. Density is often unique to a given material. Physics texts list densities of materials as an aid in identifying unknown materials. Here's a problem to work out. If the density of a gas is 1.5 grams per centimeter cubed, what is its density in kilograms per meter cubed?
Correct.
A variable called specific gravity is also used to identify materials. The specific gravity of a material is a ratio of its density divided by the density of water at 4 degrees centigrade and 1 atmosphere of pressure. The density of water under standard conditions is 1,000 kilogram per meter cubed, or 1 gram per centimeter cubed. What is the specific gravity of aluminum if its density is 2,700 kilogram meter cubed?
Try again. Correct.
This person is exerting a force on the box. The force divided by the area under his feet is called pressure. In this case, the pressure is the person's weight, newtons, divided by the area covered by his feet, in square meters. If the area of the person's shoes is 0.01 meters squared, and the person's mass is 53 kilograms, what pressure is being exerted on the box?
Try again. Correct.
Consider a fish swimming below the surface of a lake. The weight of water above the fish creates a pressure on the fish. Let us calculate that pressure. Begin by considering a column of water of cross-sectional area A extending from the surface to a depth h. What is the pressure on the surface at the bottom of the column? Pressure is force divided by area. The force is due to the weight of the water in the column. The contribution of atmospheric pressure will be ignored. The force on the surface at the bottom of the column is due to the weight of the water above it. The weight force is equal to the mass m times the acceleration of gravity g. What is the mass of the water? By the definition of density, density rho is the mass m divided by the volume v. The mass is therefore the density times the volume. The volume is the column height h times the area a. Substitute this into the equation for the mass. Now substitute for the force. Finally, calculate the pressure by dividing the force by the area. The area cancels. The final result is that the pressure at a depth h is equal to rho gh. What is the pressure felt by the fish? They are at a depth of 5.0 meters. Use 1,000 kilograms per cubic meter for the density of the water.
Correct.
The pressure from a fluid exerts forces against any object, like this balloon, immersed in it. Notice that the forces F sub p on parts of the object's surface due to the pressure are directed perpendicular to the surface of the balloon. Because a fluid such as water is nearly incompressible, its density can be taken to be constant. In the equation for hydrostatic pressure, P equals rho GH, the pressure depends only on the depth below the surface. Note that the pressure on the lower part of the balloon is higher than that on the upper part. We will explore the implications of this in the next section. What is the difference in pressure between the top and bottom of a cylinder that is under the water? The area of the top and bottom of the cylinder is 1.0 meters squared. The cylinder is 2.0 meters long, and it is upright in the water with the top 1.5 meters below the surface.
Try again. Try again. Try again. Correct.
A barometer is a common instrument used to measure atmospheric pressure. In the mercury barometer, the weight of the mercury in the tube exerts a downward pressure that matches the atmospheric pressure. The space at the closed end of the tube is a vacuum. A column of mercury 760 millimeters tall balances the average air pressure at sea level. This is the standard atmospheric pressure, 1 atmosphere, equal to 1.013 times 10 to the 5th pascals, or 14.7 pounds per inch squared. Because weather causes variations in the atmospheric pressure, the barometer is commonly used for weather observations. Another instrument that measures pressure is the aneroid barometer. The aneroid barometer has a vacuum inside it, against which the outside pressure is compared. The faces of the barometer's drum move in and out in response to the external pressure. A tire pressure gauge measures the difference between the pressure of the air inside and outside a tire. The pressure in the tire pushes the piston to the left, compressing the spring, while the air pressure and the spring push to the right. What if a tire gauge reads 30 pounds per inch squared on a day when the atmospheric pressure is 14 pounds per inch squared? What is the air pressure in the tire?
Try again. Correct.
The hydraulic lift is able to lift large weights with a small input of force. A small pump can lift a car weighing thousands of pounds. Pascal's principle states that an increase in pressure in a fluid is felt throughout the fluid. In the hydraulic lift, the pressure applied to the narrow piston is equal to the pressure increase on the larger piston. We can calculate the force exerted by the large piston in terms of the force on the narrow piston. The subscript I refers to the small piston and the subscript O refers to the large piston. The force on the small piston is multiplied by the large ratio of the areas of the two pistons to obtain the force on the large piston. The narrow piston must be moved down a large distance to move the larger piston up a small distance. The volume of fluid displaced by the narrow piston equals that pushing the large piston up. Suppose that the area of the small piston is 50 square centimeters and it is pushed down with a force of 50 newtons on it. How much force is being exerted upward by the large piston with an area of 2.0 square meters?
Try again. Correct.
What's the pressure at 35 meters depth of water for average conditions? Do not neglect atmospheric pressure.
Correct.